Good morning. My name's Eric Maddox. I'm here with Eugene Glenn discussing his new book, Evidence Clearly Seen, and it is excellent. I think I just picked up another reference book that I'll be using for years. This thing is so full of information. Eugene, can you give your name and your background?
Yes, Eugene Glenn. I'm an electrical engineer for the last 40 years. I'm also minister of the gospel of Jesus Christ. And I feel God wanted me to write this book because it's based on Romans chapter 1, verses 19 and 20. And it's really speaking of ways to see God in nature.
Yeah, that was what I was going to ask. It was, how did you come up with this evidence clearly seen? And you just answered that question before I asked it.
Yes.
Can you tell me something about cognitive load?
Cognitive load, I wrote a whole chapter on that. I believe that's like chapter 4 or 5.
Yeah.
Cognitive load is an area of study that was not developed by proponents of intelligent design. It's something that's used in industry, it's used in education, and so it has to do with whatever a person does. There's a certain amount of cognitive load involved. So we recognize when we're getting stressed because we can get overwhelmed by so much information that we're trying to deal with, so many decisions that we have to make. And so anytime you're designing something, there's a certain amount of cognitive load involved. When you're studying something, when whatever you're doing, when it comes to humans, we are far advanced than any other creature on the earth. That's not to say that they don't have any cognitive load. It's just that their levels of cognitive load can't get above a certain amount of levels. So one example that I mention in my book is how a cat will chase a mouse. When it sees a mouse going across the field, it doesn't head towards where the current position of the mouse. It'll actually head toward where it thinks it's gonna meet up.
He's making a calculation for
Yeah,
intercept. Yeah.
yeah, and so this is something we use in even our most advanced missiles and things of that nature. So it indicates an ability to foresee what's going to happen in the future. So it takes a certain amount of internal, what would you call that? It's an imagination. It's part of what we use to model what is happening in the world, and we're able to practice things ahead of time. And so, like I said, even a cat can do that.
Mm-hmm.
And but if you go down to the smallest level of creatures, like an amoeba, if it sniffs its food or nourishments in a certain spot, it just goes towards that. It won't know if the thing is moving. It has to keep taking readings and then try to follow whatever it can smell.
Right. I see cognitive load when I used to fly, and it was like I had probably a dozen balls in the air, so to speak. You had to be doing something, uh,
A pilot?
yeah,
Oh,
very conscious of what you're doing and what you're going to have to do the next second, what you're going to have to do the next second, and it all has to come together
hmm,
at the same time.
yes. So when it comes to um, designing something complex, um, humans have a unique ability to use what we call abstraction. So um, that's what gives us the ability to read and write, something that the animals can't do.
Yeah, yeah. I heard somebody this quoting someone said, uh, "We think the thoughts of God after Him,"
Mm,
and that's what a scientist is. And even if you don't acknowledge Him, we do that in everyday life about any task we have to accomplish.
right.
Yeah.
So chapter one is all about um, the the watchmaker argument. So when we see a watch, we intuitively know by its complexity. If you open it up and you see all um, the clockwork going on inside, and how it all has to mesh together and interface those cogs, and it's such high precision that we know it took a lot of thought, a lot of planning, and a lot of precision.
Yeah, that you've got like 20 motions all going on at the same time, all accompanying the other to
Exactly.
make it work. Um, can you elaborate on the idea or the of irreducible complexity?
Irreducible complexity um, was developed by Michael Behe. The idea that that's an intelligent design construct that actually applies to anything we make. Um, he uses a mousetrap as a very basic, um, irreducible, complex system. So to be able to catch mice, it has to have at least four different parts that interact,
Hmm. Hmm.
and including the little thing that holds the bait, and you have the bar that is triggered if the bait is moved, and then you have the hammer part that swings down
Yeah,
on the mouse.
and the idea being if you have any one of those missing, you don't have a mousetrap.
Exactly.
It's not you have three quarters of a mousetrap or 90% of a mousetrap.
Right.
It doesn't work.
Right.
Yeah.
So um, things like a mousetrap um, have been criticized because uh, people will say, "Oh, well, you can make different versions where all you need is a brick that falls down," or
Hmm.
there's different types of mousetraps, and the thing is, whenever we design something, the thing that makes it um, easy to detect design is not just one system where we're looking at irreducible complexity, but I try to highlight how irreducible complexity also has to have a certain level of precision to
Absolutely.
go with it. So
Yeah.
the more precise a thing is, like um, the, the the mechanical watch, where you have so many pieces that have to be each each gear has to be completely precise. All the teeth in each one have to be precise,
Yeah.
and they have to be able to mesh with everything else and assembled
Mm-hmm.
to a point where uh, no other creature could assemble it. You
Right.
know, even if you give them all the parts,
Mm-hmm.
only a human has the ability to actually assemble it.
Yeah. In I used to work at Holmes Tuttle and talk to a lot of the mechanics about vehicles and what makes them work and what makes them not work.
Hmm.
And they say, okay, let's say you have a brand new Ford pickup and you have 99.99% of it all complete, ready to go,
Hmm.
but it doesn't have spark plugs.
Exactly.
It does not work. You have to have everything engineered perfectly all
Exactly.
at the same time. And that
Exactly.
makes it mind-boggling how God orchestrates everything in living systems and in non-living systems.
Right.
Yeah.
Right.
So
So over 200 years ago, William Paley came up with the idea of the watch.
mhm.
You know, and he didn't talk about irreducible complexity, but we all naturally understand that when we see something as complex as a mechanical watch or even an electronic watch. You look at the parts involved. You know, if you take out just one piece, it ain't gonna work.
yeah, yeah. You don't have 99% of a machine to work. It doesn't work. Yeah.
Exactly.
And in living systems, let's say within a cell,
Hmm.
like Dr. Behe would say, irreducible complexity. Let's say uh, you have a cell, but it can't convert um, to sugar.
Hmm.
So the cell dies. So that information is not passed on. And that's in the genetic code that is. Why don't you talk about the genetic code, how it is self correcting? And
Yeah, the genetic code. Um, you don't even have to get that deep into it to realize that it's of 4 characters. It also is attached to sugar that is all right-handed. Sugar phosphate, that that backbone that you see along the edge of DNA, that's called a sugar phosphate backbone, and it 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 has only right-handed sugar molecules. Sugar molecules can be left-handed or right-handed. When you make them from scratch, it's an equal mixture.
yeah, yeah,
So every molecule has to be hand-picked, and you have to pick all the right-handed ones. Any left-handed ones is going to mess up the
yeah,
entire structure.
yeah. There was on page 126, uh, number 3. It's a piece of information that I think is just astounding. Um, the probability of correctly linking 450 nucleotides in a specific sequence with an absolute zero tolerance of 1 angstrom for each bond is astronomically low. And can you give them some idea of how big a number that is?
10 to the minus 4,320.945.
That's in,
That is, um, anytime you get above um, 10 to the minus um, 80 or so, that's more than the amount of atoms in the entire uh, visible universe.
yes, yeah.
So when you
It's
start
a
getting into the
huge number.
thousands,
Yeah,
you know, you can't even say multiple universes would be able to, it'd be out of reach.
Yeah. I've talked to mathematicians and astronomers when they say when you have something that is in excess of 10 to the 150th power,
Hmm.
that's the number that they consider now it's impossible.
Yes.
And 10 to the minus 4,300, I mean, that is huge.
Yes.
Yeah, huge.
Yes. So yeah, so Stephen Meyer gets into that as well
Hmm.
in his book, The Signature in the Cell. So I discussed that as well as irreducible complexity, and we're only talking about one string of DNA that will code for um, only one single protein. So our cells are made of thousands of proteins.
Hmm.
So when you speak of irreducible complexity, you need all of those proteins before things start having the ability to start functioning.
Right, right.
So the main thing that has to function is the mechanism that can read the DNA and then convert that to proteins, all the amino acids. So, like I said, the DNA has 4 different letters, and in math we call that a base 4 language,
Hmm.
base 4 alphabet. Whereas when you convert to proteins, you have 20. So it's a base 20. And like I was speaking about earlier, only human level or higher can think in the abstract well enough to make this kind of conversion between one base unit using a base 4 letter system to a base out to a base 20 letter system.
Hmm.
Anybody that's taken any kind of advanced math, uh, even in high school, and studied the basis, converting between like binary or hexadecimal, those are all different base uh, uh, lettering systems,
Yeah.
numbering systems.
Um, I think it was in Dr. Meyer's book. He says the number of specific proteins necessary for DNA to replicate
Hmm.
was 75
Hmm.
specific proteins. But these only come into existence at the direction of the DNA.
Exactly.
It's like,
So that's like Behe would say, that's irreducible complexity
yeah,
all
yeah,
the way down.
yeah, yeah,
Every single part has to be there from
yeah,
the get go before you get life started.
yeah. There's something that when I would teach high school kids, it was one of these I don't believe it moment when I would say that's the information in a single strand of DNA
Hmm.
is the equivalent of about 1 million pages of the most complex biochemical information you could imagine.
Exactly.
And how much information is that? Well, we don't use encyclopedias much anymore, but 23 different books, 23 different books, about 25,000 pages. That sounds like a lot.
Hmm.
Multiply that by 20,
Right.
and
That
you've got that in approximately 37 trillion cells in your body.
exactly.
That's awesome.
So that's why when we think about how DNA is strung together, it's just like these beads on
Yeah,
the
yeah,
string. You have to get every single letter linked together, and the amount of accuracy just to get two of them together at this at the size of one atom is that's an astronomical number right there.
right.
And then to get a third one, you got the same kind of problem. And this is the same issue, not just with the DNA, but with the proteins. When you want to construct those, you have to have machinery that has this kind of accuracy on the atomic scale. So we're talking about the angstrom, the width of an atom is called 1 angstrom,
Yeah,
and it's like super accurate, far beyond what the accuracy we need to create the parts for a mechanical wristwatch.
right.
So we're talking about a million times the accuracy.
Yeah. And then something that when I think about it, every time I just have a wow moment. It's like all of that information has to be there exactly the same time.
Exactly.
Yeah,
And um, the thing about what they use for evolution, what they call natural selection, um, Charles Darwin said, "Hey, his theory breaks down when you can't find a way for um, a system to gradually evolve from one type to another." Well, he never discussed the origin of life. He didn't know anything about DNA or protein sequencing.
yeah. I think that gets into the impossibility of uh, life just happening. It's like
Exactly.
he had no idea of the complexity of what was in the cell. Yeah,
Exactly. So yeah, a lot of people say if Darwin would have um, grew up in our time, knowing uh, the complexity involved within the cell, what we know today, he might not be a Darwinist.
yeah. He wouldn't have written the book.
Exactly,
Yeah, yeah,
because back in his time, it was just assumed that a cell was just a little glob of jelly,
yeah, yeah,
jello or whatever.
yeah. One of the things that I really derive a lot of pleasure from is on YouTube they have videos of their animations, of course, of what's going on inside the cells. You
Hmm.
have nano machines, and it's just like talk about jaw dropping. It's like,
Exactly.
and that's going on
And
all the
that
time, all the time.
and that's why in the book I put a lot of links in there, because the book is intended to to use those links, those QR codes, to follow along with the videos. It's very helpful
Yeah.
to click on those QR
For
codes
example, if you could see that, there's you've got these all through the book.
all through the
Yeah,
book,
yeah, yeah,
and because it's so helpful. Um, a lot of people get overwhelmed when they start reading up on all these details. The videos help you
oh yeah, yeah,
enormously to see what we're talking about and get that to visualize it, because it's like you said, it's a lot of it is animated, but there's even if you use um, real cameras, you know, microscopes, you can actually see with when you look close at one cell, they're mostly translucent. I mean, you can actually see things moving around inside of them.
Mm-hmm.
So even that is amazing.
Can you define biogenesis and how abiogenesis is impossible?
Yeah. So that goes along with everything we're saying with when it comes to the watchmaker argument of chapter 1. Abiogenesis is speaking of how it is assumed by many scientists that life just came together out of some pond somewhere where all of the different chemicals came together, and maybe there was some lightning storms and zapped them, and you get some amino acids forming. Well, a few amino acids is not enough, and like I was saying earlier, it comes when you make them from scratch. They come in left-handed and right-handed versions.
Right. They're
When
mirror
it,
image, but
yeah.
only one is usable.
So, like I was saying earlier with DNA, that backbone of the DNA only has the right-handed sugars have to be hand-picked.
Mm-hmm.
Whereas when we're talking about amino acids, they only use the left-handed version of the amino acids to make proteins.
Mm-hmm.
Those have to be hand-picked.
Mm-hmm.
And so when researchers doing a biogenesis research, the only way they can get that purity with only left-handed amino acids, they have to buy it.
Mm-hmm. Mm-hmm.
They have to order it from
They have to mentally
a shop
think. Yeah.
that will provide them those chemicals that they've done all kinds of processes to get that purity. Like I said, when you first make them, it's 50%. Yeah, 50% each, left hand and right hand.
Right.
But to make their thesis and their research work, they don't have time to say, "Hey, I got to pick one uh, all these left-handed amino acids, and then I can get to my next step of trying to prove
Right.
abiogenesis." That's why abiogenesis has not gone anywhere since 1952 when they did the Urey Miller experiment.
Yeah. Can you explain that? What
Well,
that experiment was?
that experiment was put together by these two scientists, Urey and Miller. They used certain chemicals that they said, okay, maybe these chemicals were around in the early Earth, and they put them in a flask and they zap them
Yeah.
with high energy electricity, and then they examine the chemicals, and they said, oh, we see a few amino acids in there. That is their clue that life must have arisen by just chance processes that would go along with what they believe from natural selection, and somehow those chemicals evolved into a living cell.
Mm-hmm. Well, whenever I read that, I see the propaganda behind what they only tell you what they want you to know. What they don't tell you is what else was produced in that sparking chamber.
Right.
Tar
Yes.
and carboxylic acid, which
Exactly.
both are absolutely toxic to anything that would be living. So,
And one of the biggest things that's toxic is water and air,
yes, yes,
oxygen.
oxygen, right?
So 2/3 of the earth is
Yeah,
water.
yeah. And what they visualized was that the early atmosphere had no oxygen
Exactly.
because oxygen is reducing, and you have anytime you have sugars or amino acids in the presence of oxygen, they break down.
Exactly.
And when you try to say, well, there was no oxygen in the early Earth's atmosphere, you say, well, tell me, was there water?
Right.
Water and sunshine disassociates into hydrogen and
Oxygen.
oxygen. What
Yes.
about ozone?
Yes.
Oxygen.
Yes.
Yeah.
But even with no oxygen in the atmosphere, your chemicals are going to be stuck in water.
Yes. Yeah.
So water destroys them as well.
Yeah. 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 You have to have it for life, but if you have it, you can't have life arise.
Exactly.
Yeah.
So that's why I speak of scientists like uh, James Tour, who's a really big expert in what we call nanotechnology, and he realizes how hard it is. He makes things using nanotechnology in his science group, and they know how hard it is to make things from scratch. You have to put a lot of thought into it.
Right.
You have to put a lot of engineering into it. You have to put a lot of planning into it. And um, like you said, when it comes to oxygen and water, you have to protect it against whatever you're trying to build. You have to protect it against those things, and you have to take steps every piece along the way as you're trying to build a structure that has to say, okay, I got these three. I need another one attached to it. I have to I have to take steps that nothing else gets attached to the sides,
Right.
for it to come out as a string. You have to have only that attachment. You can't have that attachment
Right.
from the side. Um, and and it takes lots of them like this. This is about 50.
It's not a couple billion.
Yeah,
It's not a couple billion.
and this is just enough for one protein, one very small protein. It'll fold up into some shape based on the code,
Right.
and that shape will be able to accomplish some specific task in a cell if every letter in that code is correct. If you take, like that one's got an M right there, if you replace that with an N, this whole string is messed up.
Yeah. Yeah.
It's just like a word uh, or a sentence. You change one little thing in it. When it comes to computer code, that generates errors.
Yeah.
You can't have not even one wrong letter.
Mm-hmm. I mentioned earlier one of the guys that I follow, Guillermo Gonzalez,
Hmm.
is a astrobiologist,
Hmm.
and comes up with what are the parameters necessary for life. And he's come to the conclusion that it's impossible, because every time you look at another star that has a planet around it, first question, is there liquid water?
Mm-hmm.
Well, no. Well, if you have liquid water, you're not going to get life arising out of it. But if you do have life, you're not going to have life surviving unless you have liquid water.
Right.
So, and his conclusion was there were something like 30 different parameters. Any one of those, if you don't have them, you don't have life, or life is not maintainable. But he said there are probably thousands or even millions of them that we're completely unaware of. So
Yeah.
yeah.
Yeah. So the whole idea of irreducible complexity applies anywhere in the universe. And it's not just a matter of having the proper ingredients. You have to have keep outs of things that would destroy the life.
Yeah.
You know, if it was that easy, nothing would die. Where you have a living cell today, you can take a bacteria, you can kill it and sit it out and say, okay, give it enough time. It's based on the theory of abiogenesis. It should just, on its own, just come back to life.
Yeah. I think something that they overlook, or they don't want to even talk about it, is second law of thermodynamics.
Mm-hmm.
Like, okay, let's give them a billion years.
Mm-hmm.
Well, that only makes their situation worse, because it increases entropy, which is chaos and heat energy not available for work. And so, okay, with all the time they need, it gets worse for them. Well, if they don't have any time, well, that removes part of the definition of evolution. Evolution over time.
Yeah.
Well, they need deep time, but that doesn't do them any good.
Yeah. And that's why James Stewart points out not only entropy problems, but what we were talking about earlier, if you don't protect it, billions of years is very, very harmful.
Yeah.
You know, the more time is actually harmful.
Yeah.
You have to put this thing together fast.
Yeah. It's like I use the illustration with high school kids. I say, let's say you had a Volkswagen 100 years ago and you put it out in the desert.
Mm-hmm.
Theory of evolution said that thing should have turned into a Ferrari by now.
Exactly.
Let's go look at it. Well, can we even tell it was a Volkswagen? Yeah. So,
Yeah.
Anyway.
So yeah, all that rust and everything, it happens even on the cellular level with the oxidation.
Unless it's in the movie Sleeper, where Woody Allen gets in this 200-year-old Volkswagen and it instantly starts.
I haven't seen that one. That sounds good.
It's ridiculous. So, anyway, is there anything else that you think we ought to cover today?
It's up to you.
How about 2 Corinthians chapter 10, verse 4?
Oh, let's read that. Let me get my Bible.
Because this is what we're doing today. 2 Corinthians chapter 10, verse 4.
For the weapons of our warfare are not carnal, but mighty through God to the pulling down of strongholds.
Casting down imaginations and every high thing that exalts itself against the knowledge of God.
And bringing into captivity every thought to the obedience of Christ. That's verse 5 as well.
Amen. Amen. And that's what we're doing, brother.
Yes.
So, this has been fun.
Yes, thank you.
Yeah, you're very welcome.
Yes, I appreciate your time interviewing me here with this.
And like I said, when I started reading this, it was like not like a novel. You just go from cover to cover.
Exactly.
It's something. This is a reference book that I will use for years.
Mm.
Let's see, where did Eugene have that information? Oh, there it is. Yeah.
Yeah, that's why I thought it was important to have at least 10 chapters
Yes.
of areas clearly seen.
Yeah, absolutely.
You know, so when you think of a subject matter, in this case, we're talking about the watchmaker argument,
Yes.
but there's 9 other main areas of study, including history, including the Bible, speaking about Christ dying for us and how it was predicted. To me, that's the most important thing in the book.
Yes.
Is about how God orchestrated over thousands of years' time by giving prophecies that were written that predicted where he was going to be born, how he was going to be born, what he was going to accomplish,
Yes.
and how he was going to die.
Yeah.
And all of these details could not have been put together by man. You know, that's why I really love the Bible, because it couldn't have been written by man, because we don't like to put our weaknesses in there.
No, no.
When we speak about the writers of the Bible, all of them had too many weaknesses to have been the author.
Yeah.
You know, the author would never speak of a whole lot of problems of his own and how to get righteousness, and it only comes from God.
Yeah.
So,
and when people say they don't want anything to do with God, I'll say, well, he became a man, came to earth, he died for you.
Yes.
You still don't want anything to do
and
with
he's offering life.
Mm-hmm.
And one thing that nobody can deny is that we're all, from the time that we're born, we're already on our way to the grave. We're going to die.
Mm-hmm.
And he's the only one offering a way to live forever.
And we're all going to be somewhere forever.
Yes.
So we get to choose now.
Exactly.
Yeah.
So
anyway, brother.
Thank you so much, Eric.
It's been fun.
All right. Let me stop it here. Thank you.